Hi everyone, it's Mrs. Martello. We are going to take a look at section 5.6, and in this section we're going to look at linear inequalities. So we've been doing a lot of graphing of equations, but now we're going to look at inequalities. So a linear inequality in two variables, x and y, can be written in this form, which is like standard form, ax plus by equals c. But instead of it being an equal sign, it's an inequality sign. So we can have less than or equal to, greater than, or greater than or equal to, where a, b, and c are real numbers. The solution of a linear inequality in two variables is any ordered pair that makes the inequality true. So because it's an inequality, there are going to be many solutions. It's anything that makes it true. It could be anything greater, anything less. So keep that in mind. Our first example here is we're going to tell whether the ordered pair is a solution of the inequality. So they're giving us an inequality and then they're giving us a point, and basically we want to take the point, plug it into this inequality, and see if the point makes the inequality true or false. So let's look at A. We have 2x plus y is less than -3. If I plug in -1 for x and 9 for y, let's see, this would be -2 plus 9 would be 7, but 7 is not less than -3. Because this is false, that means that the point is not a solution of the inequality. Let's look at part B. X minus 3y is greater than or equal to 8, and we want to plug in the point to -2. So 2 minus 3 times -2 is greater than 8. Yeah, this would be 8 on the left is greater than or equal to 8. So because this point makes it true, that means that 2 -2 is a solution. Okay, so for this, you're just taking the point and plugging it in to see if it makes the inequality true or false. Let's go down here to this next part. Now we're going to talk about graphing inequalities. So when you graph a linear inequality, the first step is to graph the line, which is kind of called the boundary line. But then we also have to think about the inequality. So it shows all of the solutions of the inequality, not just what's on the line. We have to show what's greater than or less than. So if we take a look at this line here, you should notice that it is a dashed line. The reason that it's dashed is because in this example, it's only where y is less than 2x. So if it's less than, that means that it cannot equal it. So if it cannot equal it, that means that it cannot be any of these points on the line. So you represent that with a dashed line. When you say y is less than 2x, we also need to include all of the points that are underneath the line. So because all of this is under the line, you shade it, and that's how you represent that any of these points would make it true. And this area that's shaded is called a half plane. So that's just so you know the vocabulary. Let's go over here. We're going to write down our steps. I would definitely suggest you pause the video and write these down, or get them from your textbook. We're on page 269. So your first step is you're going to graph the boundary line for the inequality. So however you want to graph it, or if you're going to use slope-intercept form, or if you're going to use x and y intercepts, that's totally up to you. You decide. But don't forget, we have to think about what kind of line we're going to draw. We're going to use a dashed line or a dotted line if it's less than or greater than, because it cannot equal it. But we would use a solid line, so just a regular straight line, if it's less than or equal to or greater than or equal to. Then we want to decide where are we going to shade. So what we can do is we can pick a test point that's not on our boundary line that we drew. We could plug it in just like how we did in example 1, and we can see if that point makes it true or false. You can also just kind of think about where it is on the graph. If it's greater than, you're going above, and if it's less than, you're going below. Okay, when you test the point and it's a solution, that tells you which side to shade. Okay, so it's just kind of a way to check your work, and I'll show you both ways to do it with the test point and to just think about if it's greater than or less than. Let's take a look at example 2. Now in example 2, we only have one variable here. It's only a y. Remember, when it's y and a number, it's only going to be a horizontal line. If it was x and a number, then it would be a vertical line. So let's graph this line here. First, we're going to graph the equals, y equals 2. So we would go on the y-axis to 2, and you draw a horizontal line right through here. it would be a solid line because it says or equal to. So it is a solid line. Now we're going to decide where we're going to shade. So we can pick a test point. A good point to test is 0, 0, as the origin is a good point. As long as it's not on this line, that's always a good point to choose. So if I take 0, 0 and plug it into my inequality, I get 0 is less than or equal to 2, which is true. So because 0, 0 makes the inequality true, that means that all of these points underneath the line would make it true. So I would shade all of this area down here. Okay, you can also think about it because it says y is less than 2, it would be below the line is where you shade. Okay, let's take a look at example 3. So in example 3, we have negative x plus 2y is greater than 2. So we need to figure out first how we're going to graph this line. Let's show our work on a piece of paper so that we make sure that we know how to graph this. Okay, let me write this down. We have example 3. Our inequality is negative x plus 2y is greater than 2. Now, in order to graph this, we could put this into slope-intercept form, make it y equals mx plus b, or we can find the x and y intercepts by plugging in 0 for x, solving for y, plugging in 0 for y, and solving for x. And that's totally up to you. I think it's easier to use y equals mx plus b. So let's solve this inequality for y, solve for y, so that I can get it in y equals mx plus b form. And then we're gonna graph it from there. So here we go, we're gonna isolate the y. Let's add x to both sides. We get 2y is greater than x plus 2. Let's keep solving. We're gonna divide both sides by 2. And remember, we're doing the heart method. Remember, there's a 1 in front of this x. We're going to divide each of these terms by 2. We get y is greater than, on this first term, remember we want to put the numbers in the fraction, push x to the side, so it's going to be 1 over 2 x plus, we're going to divide these two numbers here, would be 1. And there would be our inequality, just like that. Okay, now that I have my inequality, I'm ready to graph. So I'm going to go over to my graph paper. Let me write my inequality down. Y is greater than 1/2 x plus 1. I'm going to draw my coordinate plane on the graph paper here. Okay, now when you graph this line, remember it's an inequality. So there are 2 extra things that we need to think about when we're graphing this line. Our first step is we need to decide what kind of line is the graph going to be. Is it going to be a dotted line or is it going to be a solid line? Because this inequality is only greater than, it's not equal to, that means I need to use a dotted line. My line is going to be dotted because it cannot equal it. So let's do that. We're going to plot our y-intercept. We always start at the y-intercept here of 1. And now let's use our slope. Remember, rise over run. So I'm going to rise 1, run 2. Up 1, right 2. Do it again. Up 1, right 2. Remember, I can go the other way too. I can go down 1, left 2. Down 1, left 2. Okay, that should be enough points. We're ready to draw our line. Don't forget, we said that it is dotted. So when we draw our line here, we're going to use a dashed line. So we're just going to do dashes all along here. We still do want to put arrows on the end because the line does go on forever. And our second step we need to decide is where are we going to shade. So to shade, what we can do is what the book did, we can pick a test point. So I'm going to show my work up here. We know that 0, 0 is not on the line, so 0, 0 is a good test point. Let's test 0, 0 in our inequality. We could plug it into the original inequality or the new inequality. It doesn't matter. I think I like the original one better in case if I made a mistake in solving it here, and if this one was wrong, then it might tell me the wrong thing to do. So I'm going to plug it in this original inequality up here. So we're plugging it into negative x plus 2y is greater than 2. Let's plug in 0, 0. So it'd be the opposite of 0 plus 2 times 0 is greater than 2. These would both cancel out. We get 0 is greater than 2. No, that's false. So because this is false, that means that 0, 0 is not a solution. So since 0, 0 is below the line, that means that all of this is not a solution, meaning the other side, this half plane, would be where the solutions are. So I'm gonna shade all of this area up here, and I'm just using my pencil and just kind of shading that area lightly, just like this. Okay, I just want you to think about it in an easier way. You don't have to do this test point. You can do it a bit easier. Since this was a greater than symbol, that means that I should be shading above the line, shade above the line. And that's why we're shading up here, because it's greater than. Okay, we're gonna take a look at two more, just to make sure we got the hang of it. So I'm gonna go down here to monitoring progress. And we're gonna take a look at monitoring progress number 6. We have x is less than or equal to negative 4. Now remember what we said, if it's only in one variable, it's gonna be either vertical or horizontal. Because this is only an x, this is gonna be a vertical line. Okay, so let me draw my coordinate plane here. Okay, remember we need to think about what kind of line is this going to be and where are we going to shade. So I know it's going to be a vertical line because it's less than or equal to. I know it's going to be a solid line because it's or equal to. When it can equal it, it's going to be solid. So let's go on our x-axis to negative 4. 1, 2, 3, 4. Let me make this a little bit longer just so we can see it. So 1, 2, 3, 4. And then we're drawing a vertical line right through this point, and it's going to be solid this time, again, because it's or equal to. And there we have our line. Okay, we still need to decide where are we going to shade. So again, we can pick a test point and plug it in. If I were to test 0, 0, which again is not on the line, I would only plug in the 0 for x. 0 is less than or equal to negative 4 is false. So I don't want to shade on this side, I want to shade on this side. But also, when x is less than negative 4, that would be all of these numbers over here. All of these are less, so we would shade everything to the left. So I think it's just easier to think what direction am I shading rather than doing the test point, but you can always do the test point as well. Okay, we're gonna do one more. We're looking at monitoring progress number 8. And now for number 8, we have a little bit of work to do for this inequality. X minus 2y is less than 0. Since this inequality is in standard form, I either need to change it, put it into slope-intercept form, which is y equals mx plus b, or I can use the x and y intercepts. I like using y equals mx plus b, so why don't we go ahead and solve this equation or inequality for y. So I'm going to solve for y. Let's subtract x from both sides. I get negative 2y is less than negative x. Let's keep solving for y. I'm going to divide both sides by negative 2. Now be careful. Remember when we did this back in chapter 2? When we divide both sides by an inequality, what do we need to remember to do? Right, we need to remember to flip the inequality symbol. So here our first step was we solve for y. And our second thing that we need to remember is if you multiply or divide both sides of an inequality by a negative number, you have to flip that inequality symbol. Flip the inequality sign. All right, so let's write our answer here. We're gonna get y is greater than, Okay, we remember there's a number in front of here. It's really a -1. We're going to reduce it. So negative and negative make positive. Put the numbers together. It'll be 1/2. Push x to the side. So y is greater than 1/2 x. Okay, we're ready to graph this on our coordinate plane. Let me write it down again. Y is greater than 1/2 x. Okay, here's our coordinate plane we're going to graph. All right, let's think about what we're going to do for this one. First, what kind of line are we going to use to graph this inequality? Think about the symbol that's here. Because it's not equal to, it's just greater than, that means that we're going to use a dotted line, Okay, so let's graph the line. We want to start at the y-intercept. Remember, this is y equals mx plus b. Well, there is no b in this equation, meaning that it's really plus 0. So 0 is our y-intercept. Let's plot that point. And then we're going to use our slope, rise over run, up 1, right 2, up 1, right 2. Let's go the other way, down 1, left 2, down 1, left 2. Okay, we're ready to draw our line. Don't forget it's going to be dotted. So we're going to use dashes to draw this line. And now let's think about where are we going to shade. Because this is y is greater than 1/2 x, I'm going to shade above the line. If it was less than, I would shade below. Greater than is above. So I'm going to shade all of this area up here above the line, just like that. Okay, and that's us graphing our linear inequalities. We're going to take a look at one more. Let's look at this real world example on the next page, example 4. So here would be an example of a real world problem. You can spend at most $10 on grapes and apples for a fruit salad. Grapes cost $2.50 per pound and apples cost $1 per pound. Write and graph an inequality that represents the amount of grapes and apples you can buy, and then identify and interpret 2 solutions of the inequality. So let's think about how we're going to write our inequality here. We're going to have the cost of the grapes times how many pounds of grapes we're going to get, plus the cost of the apples times how many pounds of apples we're going to get, and that's going to have to be less than or equal to the total amount of money that I want to spend, because it says at most $10. So if I can spend at most 10, I can spend 10 or less, so less than or equal to. So let's write our inequality. It would be 250x plus 1y is less than or equal to 10. So again, that would be our inequality here. And we want to now graph it. So when we graph it, we're going to graph either using y equals mx plus b, or again, our slope, our x and y intercepts. They solved this inequality for y. They made it into y equals mx plus b. So they got y equals negative 2.5x plus 10. It would really be less than or equal to. So don't forget that it is an inequality symbol. So let's graph that on our coordinate plane. You start up here at 10, and then our slope, this would be negative 5/2. So we would go down 5, right 2, down 5, right 2, and draw our line. This would be a solid line because it's less than or equal to. And then we're going to shade. Again, it's less than or equal to, so we're shading everything below the line that's here. Okay, our next step is now we want to find interpret 2 solutions of the inequality. So you can pick any points you want that make the inequality true. You can pick any point in this shaded area, or you can even pick a point that's on the solid line. So let's talk about these 2 points that they picked here. 1, 6. Think about what that stands for. The 1 is the x, that stands for our pounds of grapes, and the 6 is our y, that stands for the pounds of apples. So one possible solution, 1, 6, because it's in the shaded area, and then another possible solution is 2, 5, because it's on the solid line. So you can buy 1 pound of grapes and 6 pounds of apples, that would be 1, 6. Or 2-5, we can buy 2 pounds of grapes and 5 pounds of apples. And you can pick any of these points all in here. Any combination would make that inequality true.